Important thing today we are going to do a coplanarity of two lines. Okay, means the lines lying on the plane. The lines which are lying on the plane are called coplanar. So let's take this is a plane. Suppose so take it more bigger. This is a plane. Okay. Now we have to prove that the two, what will be the condition that the two lines lying on the plane are coplanar. So let's take that L1 is a line which is lying on this plane. And its vector equation is vector R is equal to A1 plus lambda B1. And you know that this is the condition of a plane of a line passing through a point. So let's take a point. Suppose I'll draw first line which is lying on this plane. So this is a 1 minute. This is a line L1. This is what line L1 lying on the plane. This is suppose L1 line. L1. And as you have seen, this is the condition that the line passing through a point, and this is a point A from which this line is passing, and it is parallel to a vector B1. So let us take that vector which is parallel. Okay, just leave it that vector. We will go to the next line, then I'll tell you that one. So L2 is a line whose vector equation is A2 plus mu times B2. This is another equation. Okay. So let's draw this line, and suppose that this is L2. This is L2 line. And as you have seen from the equation, this is also passing from a point B, that is B. Okay. Then it is a Cartesian coordinate system, 3D system. So we have to take the X, Y, and Z axis. Yes, what is the difference between skew and coplanar lines? Yes. Skew lines are, I told you, neither they are not parallel, and neither parallel nor perpendicular are called skewed lines. And the line which are lying on the plane, same plane, they are called coplanar. The lines, whether they are parallel and perpendicular, that is another thing. But if they are lying on the same plane, they are called coplanar lines. And you are asking about the skew lines. Skew lines are neither parallel nor perpendicular. That is possible in 3D. I explained you by taking a cuboid on the roof. One, if you remember, I drew one line on the roof and another line is from one wall is passing. So they are not intersecting, but they are not parallel to each other, neither parallel nor perpendicular, and they are not intersecting to each other anyway. Okay, so that is possible only in 3D. So this is a Cartesian coordinate system. z-axis. Okay, x-axis, x-axis, y-axis, and z-axis origin. We have to see the condition of coplanarity. What is the condition that the line are coplanar? Okay. Now, this L1 is parallel to a line. As you know that it is parallel to B1. So, this is suppose B1. B1 line is parallel to this line L1. Okay. Then B2 line, there is a line, another line which is parallel to this line B2. So B2 line is parallel to this line. These two lines meet at this point. Okay. Now we have the position vector of A. The position vector of A is OA. As you know, from O to A, this is the position vector. Okay. This is the position vector of OA, and this is the position vector of OB, and we represent it by vector A1. This will be vector A1 and vector B1. Okay, and this is what? This is B1, vector B1. This is vector B1, this one, and this is vector B2. Okay, now if you join this A to B, join A to B, A to B will lie on the plane also. A to B, so AB, this is the vector joining AB point. Okay, now one important thing that I am going to discuss now, that A cross A1 cross B1 or AB cross, what is represented by the vector which is perpendicular to both the vectors. So if we draw a vector which is perpendicular on this both vectors, it is perpendicular on these both vectors. This is perpendicular to both the vectors. It is perpendicular to the plane also. You can say this is the normal also. This you can say it is also the normal to the plane, and this is passing from the plane. Okay, inside from the you can show like this. It is coming out from the plane like this. Okay, like this. So this is the perpendicular on the plane which is showing the direction. This is represented by B1 cross B2. This is represented by B1 cross B2. As you know that by the rule, screw rule, if you move this in this direction, means if you will move from this direction, the screw will go up. So that's why this is, it is having direction this one, and B1 cross B2 and AB. Now, if you see this 3D diagram, this B1 cross B2 is perpendicular to AB. Since now AB vector AB is perpendicular to B1 cross B2, correct? Because B1, B2 is the perpendicular or normal to the plane, and AB is lying on the plane. So they will be perpendicular. Every line which is lying on the plane will be perpendicular to the normal to the plane. And one more thing, just remember that DRs of the plane are the DRs of the normal. Whatever the DRs of the normal, they are the DRs of the plane. So we used to say DRs of the normal, DRs of the plane, same thing. Now they are perpendicular. As you know, if the two lines are perpendicular to each other, their dot product is 0. Therefore, we get A B dot B1 cross B2 is equal to 0. Is equal to 0. And AB, you know that AB from the triangle law, you know that AB is equal to position vector of B minus position vector of A. So position vector of B is B and position vector B minus A. That means AB will be equal to B minus A. That we have seen already. B minus A, position vector of B minus position vector of A dot B1 cross B2. So this is the condition. If you are getting B1 cross B2, find out, and dot product of this with B minus A, if it is 0, we can say that L1 and L2 are coplanar. So this is the condition for coplanarity in vector form. Okay. Now, yes. Yes, no problem. If the direction is down direction also we can take, no problem. But in this case, if in that case L1 you can take this side and L2 that side. So that's why. Okay. So down direction is also perpendicular to this. If B1 cross B2 is coming down because this, but I think we are moving from B1 to B2. From B1 to B2. So like this, if you see the screw rule, so I think this is up direction. Moving from this to this. Okay, so if it is down also, no problem, because that is also perpendicular. That's why I drew this. So this is the condition: B1 cross B minus A, B1 dot B2, B1 dot B2, B1 cross B2 dot B minus A. This is the condition for coplanarity of two lines in vector form. If you have given the Cartesian form, the same thing is given in the Cartesian form. Now, if the equation, what will be the equations in Cartesian form? Just see this. This is important. Just we have to remember in Cartesian form. I'm writing here Cartesian form. If the equations are given in Cartesian form, so what will be the type of equation? This type of equation will be given L1. L1 will be the equation which is passing through a point A, x minus x1, and its direction ratios are A1, B1 and C1, x minus x1, y minus y1 upon B1, and z minus z1 upon C1. That means in this case the coordinates of point A will be x1, y1 and z1. And similarly, if L2 is a line in the Cartesian coordinate system, so this will be x minus x2 upon A2, because this is the line passing through the point B and having the direction ratio as A2, B2, C2. So y minus y2 upon B2 and z minus z2 upon C2. So that means if Cartesian form is given, this will have the coordinates as x2, y2 and z2. x2, y2 and z2. Okay. In this case, if you will drive, you can drive it. It is very difficult, but not difficult, but it is a long process to find B1 cross B2 and then finding their dot product. Ultimately, we will get this condition will be reduced to then x2 minus x1, x2 minus x1, y2 minus y1, and z2 minus z1. You have to remember it. A1, B1, C1, A1, B1, C1, A2, B2, C2 is equal to 0. So this is the condition for coplanarity. Means if you will prove this, that means the lines are coplanar. So this is the condition for coplanarity of two lines in vector form and in Cartesian form is this one. So whenever we have to show that the two lines are collinear, we have to just apply this formula. If it is in vector form, we will apply this formula and we get the 0. That will prove that the lines are lying on the same plane. And if it is given in the Cartesian form, we will find the determinant x2 minus x1, y2 minus 1, x1, y1, z1 will come from first line. A1, B1, C1 are the direction ratios of the line 1, and x2, y2, z2 will come from second, and a2, b2, c2 are the direction ratios of the second line, and then substitute in this x2 minus x1 in this determinant, y2 minus y1, z2 minus z1, and solve it to get 0. If you are getting 0, that means it is they are coplanar. The lines are coplanar. Yes. Now we have to find the angle between these two planes. These two planes are intersecting. This is plane number 1. You can say this plane is having its vector equation r dot n1 is equal to d1. Okay. This is n1 is not the n cap. I told you the difference between that. If it is n cap, that is the perpendicular distance from the origin to the plane. Otherwise, this d1 is any distance, and n1 is the normal vector. n1 is the normal vector to the plane. And another plane is this one. Its equation is r dot n2 vector is equal to d2. Okay. Now we have to find the angle between these two planes. Okay. So in order to find the angle between the two planes, we will find the angle between their normals. The angle between the normals will be the angle between the planes, same. So if I draw the normal on this point of, this is the line of intersection, two planes intersect at the line, that is called the line of intersection of two planes. And if I draw 1 minute normal to this plane, which plane? First plane. This is first plane. So at this point, if I will draw a normal to this plane, okay, and normal to another plane, normal to another plane is this one. These are the normals, n1 and n2. These are the normals to the plane n1. This is normal n1 and this is normal n2. Okay, this is n1 normal vector, n2 normal vector to the plane. What is normal? Normal is the line which is perpendicular to the plane. I will show another normal. Suppose this is the line perpendicular to the plane. So can show like this. This is passing and then entering into the plane, and from here it will come out like this. So this is perpendicular. So these are called the normals to the plane. Okay, normal to the plane. So that means we have to find the angle between n1 and n2. Okay, if you draw the normal to this plane and suppose normal to this plane, let's draw a normal to this plane. It will be like this. It will be like this, I think. This will go to come out from the plane. Okay, it's wrong. So normal to the plane is, suppose this one is normal to the plane. From the plane it is coming out, and this is a normal to this plane. Normal to this plane. Okay, so the angle between them will be the angle. There will be two angles, obtuse and acute, you know that. So we are finding always acute angle, so theta. This will be theta. So whether I draw here normals this side or this side, the same thing. So that means the angle between the planes is the angle between their normals. And you know that n1 in n2, between n1 and n2, the formula is cos theta n1 dot n2, n1 dot n2 angle between the two vectors. Formula we will use n1 magnitude of n1 magnitude of n2, its whole magnitude. So this is the angle between the planes. So here n1 is the normal to the plane whose drs and drs of the plane. Now in Cartesian form, this is the this we considered in the vector form. So if we have in the Cartesian form, in Cartesian form, plane 1, we can say this is plane, this is our plane 1, and this is suppose our plane 2. So plane 1 has the equation as, its equation is represented by a1x plus b1y plus c1z plus d1 is equal to 0. This is the equation of plane 1, and equation of plane 2 is a2x plus b2y plus c2z plus d2 is equal to 0. So as I told you, a1, b1, c1 are the drs of the plane. So these are the drs of the n1 also normal. N1 is the normal to the plane. So drs of n1 is also a1, b1, c1. So we can also say that n1 vector n1 is, here vector n1 is what, a1, because its drs are a1, b1, c1, a1i plus b1j plus c1k, and similarly n2 vector will be a2i plus b2j plus c2k, k cap. So when you put n1, n2 and this these values, when you will put here, so obviously you will get that you have done before also, angle between the two lines. So that is equal to a1, a2. We will get a1, a1, a2 plus b1, b2 plus c1, c2 capital, and under root magnitude of n1, that is a1 square plus b1 square plus c1 square into magnitude of n2, a2 square plus b2 square plus c2 square. So from this we will get two conditions. Condition number 1, planes when the plane are perpendicular to each other and when the plane are parallel to each other. So perpendicularity, if plane 1 is perpendicular to plane 2, plane 1 is perpendicular to plane 2, then condition is what? Cos theta will be equal to 90 degree, cos 90 degree is equal to 0. The same condition that we have seen for the lines a1, a2 plus b1, b2 plus c1, c2 is equal to 0. Or for parallel planes, the condition is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Okay. Now we have the distance of a point from the plane, and after that angle between a line and a plane. So two things are left to discuss. So I think I'm going to end the meeting and you rejoin again. Rejoin.